Howdy. Today I want to go over setting up a large-scale end-to-end testing system that also integrates with your CI/CD system at a pretty large scale. To give a little bit of background on myself, set up, a E2E system where we're running over 200,000 tests a day. That's roughly, we're running 50,000 spec files a day. And then, that has, roughly developers submitting, well over 100 branches a day into the system. And the system has to handle all of that. So this video is going to kind of go over all of that. It's going to go over, multiple different areas of it, of setting up the servers, setting up the web servers, the database servers, the servers to actually run the test, how to actually run the test and what to run and when to run it, dealing with flaky tests, dealing with failures, and all kinds of that stuff that may be pain points for a lot of people. So this video is going to kind of go, there's no really order to it. I'm just going to kind of go over some different bullet points and kind of explain them. But this should, help you out if you're struggling with a more large scale system that has to support, 40, 50 plus developers, and so forth. Like I said, none of this is really in order. I'm just wrote down about 25 bullet points that I kind of want to discuss. And we're going to just kind of go through them. This could be a long video. I may break it up into two, but it'll be well worth your time to watch this video because this is stuff that, I've learned from setting things up from scratch and then having to scale drastically, and what issues like we've come across where, early on things are working just fine, but then as you scale and you get more tests, you get more developers, you get more issues come up, you've got to be able to handle those. And then you still got to make sure you're getting branches out fast. You don't want to have like a developer sit them at a branch and then it sit in the pipeline for a day. You need to get that out like within an hour, even faster. But if when you're running 200,000 tests a day, that poses challenges. So I want to kind of just touch base on some of that. Let's just get started. First topic is going to be run your automated tests on every single pull request. So a developer submits a pull request. You want to run the tests on every single pull request. You're not going to want to run, let's say you have, 5,000, tests in your suite. You don't want to run 5,000 tests on every pull request. You want to run the tests that are relevant to the change that developer is making. So if that developer is making changes on, one side of the application that's like, let's say the shopping cart application, maybe like the checkout page, modifying something like that. Well, we're going to run all the tests that deal with the shopping cart and the checkout page. We're not going to run tests that deal with, like, let's say the site had a blog on it, for instance, or something like that. We want to make sure that we just want to make sure that we're not running every test, because when you run if you were to run every test and every pull request and you're doing 100 plus pull requests a day at your company, your system is going to drastically slow down, and you're not going to get branches out quickly. And a lot of this, what I'm talking about too, is also could be, geared towards a small application, but also it's for a very large application as well. This will pertain to. I've had more experience dealing with large applications. So like one way to do like on pull requests, like let's say you're using like WebDriver IO, you could use your suites. So let's say like if you had like Jira linked to your pull request system like GitLab or GitHub, you could map a component on Jira that would map to a suite in WebDriver IO, or like the same thing in Playwright if you're doing you can map a suite to a tag, or map a tag to a component in Jira. So that would be one way to run your branches on a subset of tests every time, and that will drastically speed your thing up. If you're concerned about, well, what if something gets through? Well, for one, you're gonna when you go to do a release, you're gonna run all your tests when you go to do the release, so you can have confidence then. But when you're doing things at a much larger scale, another branch is gonna run. It could be minutes, could be hours after that would run a different set of suites and tests on a different area of the application. So that branch, if there was an issue, that branch would catch it. And then and that's going to take us further. That okay, so then an issue did get or a branch got through that is breaking a test. It somehow broke something outside what the developers intended to change, which that happens a lot, and that happens a lot. But you've got to prepare for that. And what happens then is the test starts failing. Well, you want to make sure that test doesn't start failing, like doesn't completely break your pipeline at that point, because now you have a failing test. So then, in theory, that means that every other branch that gets submitted after that is going to start failing because you have a failing test introduced, right? Well, no. What you want to do is you're going to have a test reporter that is going to store all your history of all your tests. And the test reporter is so significantly important to have. And if this is a test reporter that you build yourself, or you could use something like, there's a reporter currents.dev that I've used. That's pretty nice. You have to use a test reporter. It's so significant because when a failed test gets introduced, what's going to happen is you can have that reporter detect that, like, you see that, all right, test 1, 2, 3, 4, 5 just failed. Well, okay, that's fine. But then it sees test 1, 2, 3, 4, 5 just failed again on a different branch. So you have two failures of the same test on two different branches. That makes sense. So at that point, you're wondering, oh, something might be up. We had two consecutive failures. So at that point, we can almost think, oh, there might be a problem in the system. Well, you have to go one step further, because since you're running so many tests and so many branches, those failures can be completely unrelated. So what you want to do is you want to do a simplicity search on the is it simplicity search or Levenstein search, where you compare like the stack trace. Is the stack trace basically the same on both of those failed tests that happened 2 times in a row? And if they are, what you do, your test reporter can detect that there's either flakiness going on or that the system is broken. So once it's realized that 2 times, and you could set this threshold however you want, but I felt like two in a row is good. Once you see 2 in a row happen, then the test reporter sees, all right, something's broken with that test. We're not going to fail any new branches that go through for that specific test. And by not failing those branches because of those test failures, your pipeline continues to work like nothing happened. So you would have one branch fail, but then all the other ones would not fail. And if you're running, 100 plus branches a day in your pipeline, having that is so incredibly important, because else you would have every branch would basically just start failing, which would be very bad. Then you'd have developers mad at you and productivity would just go down, and you wouldn't be able to, as a company, you would slow down significantly. So that test reporter is so incredibly important. I can't stress it enough. Even if you're small scale, you need a test reporter. It's just so helpful. The other thing with a test reporter is you get a history, so you can also see if a test is flaky. So when you're doing it at large scale and large scale applications, tests might not fail 2 in a row, like we were in the previous scenario I was just talking about. You might get intermittent failures where the test might fail, then it might pass 3 times and it fails. Well, we don't want to fail other developers' JIRAs from that if it's not even their fault, if it's just a flaky test. So what you want to do is you want to look at those, when the test fails, you want to see if it's actually flaky. So you can also do that same similarity search on the stack trace to see if that stack trace is very similar to the other ones. And if it is, then that test is flaky, and we won't fail the branch because of that was submitted to the pipeline, because it's not the developer's fault. And that's another way to make developers happy. It's another way to make sure branches are getting through the system without having to go back. So that's super important. Like being able to detect the flaky tests is super important. That's why you need that test reporter. Use currents.dev or build your own on what you want to do. And then when you do find those flaky tests, and you can do the way to find those flaky tests, your reporter can just kind of tell you what those flaky tests are. And then you can easily disable those pretty quickly. The way you want to disable those is kind of going to be up to you. You want to have a nice system where you can maybe just click a button on the reporter and it disables that test by default and then creates a ticket for your automation team to go in and update that test and get it re-enabled. All right, let's go down. We're going to say don't merge tests with retries. If you're creating test cases that are going to be merged, don't allow those to get introduced with retries. You want to prevent the flakiness or any type of flakiness done before it even gets merged. So if a test that's being introduced has retries, you need to fail it back and it needs to pass without retries. The other thing is when you are introducing new tests, you are going to want to run that test multiple times to check for flakiness. So don't just run it one time like it usually does go through the pipeline. Have a separate thing set up in your CI pipeline where it detects that you have a new test being introduced. And if it's a new test, make sure to run it X amount of times, maybe 5 times, maybe 10 times. Run it that many times in a row or in parallel. And then you can see if any one of those places fail, you're going to fail the branch back. Store your end-to-end code in the same repo. I'm at this part right here. Store the end-to-end, store your E2E tests in the same repo as your main code. This is very important. You have to do this. If not, you're going to be doing so much manual work. If a developer submits a branch and he or she modifies something and it breaks a test, well, that branch can't get merged until that test is fixed. So that developer will have to make his code changes, get the test to work, either update the test or fix the changes maybe he created a bug or it's a new feature. A lot of times maybe it's just a new feature and they just need to update the test. Well, since they're in the same repo, it's very easy for them to do that and it's all just part of the same code. If those were if they were in a different repo and they were managed somewhere else, you're going to have issues because that branch might get merged, but then now later on that somebody else has to update that code and then you have failing tests and it just becomes a big disaster. So store the code in the same repo. You just have to do that. Down here, use a good custom reporter. Kind of went over that. A reporter is so valuable. Like with WebDriver.io or Playwright, you can have custom reporters where you send your tests. You can create just a reporter, and then you can send an API call to either your reporter or, currents.dev has it integrated into their own. They have Playwright integrated into their reporter, so it'll just kind of send it automatically. But you can kind of create your own. Creating your own reporter is kind of good too. You're storing the history of every test, so you kind of get a gauge when something fails or a test fails. You can kind of see what's been going on with that test. You can get a history of it. Whereas if you're not using a reporter that stores the results in a database, you have no history about that test. You just have the one thing. Like when a lot of people will just use like a one-off reporter for that current test run and use it locally or something, or to just that run in the CI/CD. That's no good. All it does is tell you what failed and what passed, but you have no history of it. You can't see if that test was flaky, has been flaky, or something like that. So you need that. Yeah, use Selenium Grid with infrastructure as code and Kubernetes. That's one way to go. You can also do sharding with Playwright or WebDriver.io. It kind of depends on what you're going to need to do. If you need to run multiple different browsers like Chrome and Firefox, might be good to have Selenium Grid set up. If you just need to do one browser, you might be able to just use sharding, and then with GitHub Actions or something, you can use the matrix, and then it will store the code or run the tests on multiple different machines. It's kind of up to you, but if you go the Selenium Grid route, make sure you use infrastructure as code, and Kubernetes is very helpful to do with that. You want to use Terraform to build out your grid, and then add it to Kubernetes. So anytime you need to spin up your grid, you can use Terraform, and you have the same grid every time. If you need to do testing on your grid, you can do that as well. But speaking about multiple browsers, consider testing just on Chrome. It's going to completely depend on what your application needs to do. Browsers are so much closely related these days, unlike they were 10, 15 years ago. So sometimes you might be able to get away with just testing Chrome. If you can, it would significantly speed up your pipeline. And if you do have to test for Firefox and Chrome or other ones, you maybe run a subset on Chrome most of the time, and then maybe before you release, you do Firefox as well. All right. Yeah, and when I talk about Selenium Grid, that's kind of where your tests are actually running. Let me go over more Selenium Grid a little bit, because Selenium Grid, you want to make sure you use like Selenium Grid or like a browser stack or a Sauce Labs or the sharding, so you can run your tests in parallel. That's super important because you want to be able to run like 50 tests at one time. If you're trying to run 5 tests at one time, you're not going to get very far. So you got to make sure you run a lot, and you can do that with Selenium Grid, browser stack, Sauce Labs, or sharding on through like GitHub Actions or GitLab CI. Browser stack and Sauce Labs would get expensive, so Selenium Grid might be the cheaper option to roll your own Selenium Grid, or you can create your own dedicated runners in either GitLab or GitHub. You don't want to run your tests on just one machine. That's just not going to be feasible. You might need 15, 20, 30 servers, each having 4, 8 cores on a piece. On those servers, you want to assume like one test per core. So, if a server has 4 cores on it, you're going to want to do 4 tests at one time on that server, roughly. That's a good rule of thumb to kind of stick to. All right, let's get about where the tests are going to run against. So, since you're running a lot of tests, you're gonna be hitting your application quite a bit. Your server, your web server and database server is gonna get hit pretty hard. It's almost gonna be like a brute force attack. So what you're gonna want to do is you're gonna have a dedicated web server and a dedicated database server. You're gonna want to treat these as like a production site. You're gonna want to make sure it can handle a lot of traffic. Because I've had, one of the things I've implemented, they run 50,000 SQL queries a second when tests run through the server. So that's an insane amount of queries being ran. So it's got to be handled for that. So make sure you set up your own web server and database server separately. And obviously you want to use Terraform or infrastructure as code to set that up, so you can make sure you have consistent builds, and you'll want to do that. And you can also, test different servers for different things. It's great for like upgrades and different things like that. Dedicated CI/CD runners. I kind of mentioned this briefly in the last one. When you're running, if you're running GitLab or GitHub for the way you run your tests against. So if you're not using Selenium Grid and you're using GitLab to run your tests, you're going to want to have dedicated runners for that. Dedicated runs, you're going to have one test run on one core. So if you have a runner that has 8 cores, you're going to have 8 tests that will run on that server at one time. So if you're running 50 tests at one time, you're going to want to have 10, 12, 15 servers that can handle that, depending on the size. All right, now we're down here. So we want to create a new site and database for each branch that is running the test. So let's say a developer just submitted a pull request. What you want to do is you want to create a brand new site and database for that specific pull request. You don't want this person's branch affecting other people's branches that are running at the same time, because when you're operating at this larger scale, you're going to have 4 or 5. It depends on how many you can handle, how much your company wants to spend, but you can have 4 or 5 branches running at the same time in automation. But you want to make sure that each branch that runs has a brand new site and a brand new database. So it's completely clean. from anything else. It's completely isolated, from anything else from that. And you're gonna have a staging site and a staging database where it pulls from to create that new site in your database. You want to scale your grid instances up and down. So let's say you're using Selenium Grid. You're going to want to make sure that you scale those up and down. Maybe nights and weekends you scale those down, keep them up, beefed up during the day when load is high, and scale them down on the weekends to save costs. Same thing if you're using GitLab actions you're running there. Just make sure to scale those down. Ensure tests can run 24/7. You'll definitely want to do this because branches can be submitted anytime, throughout the night, throughout the day. So make sure they can run 24/7. So one way to ensure that is you can maybe, depending on what your application does, if dates are important on your application, you can have hard-coded dates on the servers specifically. So that's one way to do it. But I've done that before and you can run into issues. So if you're starting from scratch, try to just make sure your tests will not care about the time and can manipulate the setup data to take into account if something runs at 1 p.m. or 5 a.m. And we'll get to somewhere in here about setting up the tests. Well, let's just touch on it now. So when you set up your tests, when you run, you're running, each test should set up its own data. And you're going to use an API to set up all that data. So you don't want to, if you have a bunch of setup data that needs to be done for every test, you don't want to, have the test go through the UI and do all that for you. Because that could take 5 minutes just to set up all the setup data that you need. You want to make sure you want to have, different methods built out somewhere where you can just call an API and it does all that setup for you. You give it some criteria to set up for what your test needs, and then it creates that. Maybe it creates users and different things like that. So make sure you do that. You want to and one thing in that setup data is you want to create new users for every test. Also, that's going to depend on what your application is doing. Maybe you don't have users, but a lot of applications have users to log in. So a lot of times it's good to create a brand new user on every single test. So you're not having any users that will collide with any other tests or anything like that, because every test should be completely independent of each other. So having new users is great. And when you do set up, so we're kind of in here already, but the staging database that we've talked about before, make sure it's a bare database. Not completely bare, but it has schema changes and maybe just a little bit of data on it. You want your tests to create all that data for you. And since you're doing it through an API call, it's going to take less than a second. So you want to just have a small database, because the smaller the better. You don't want to have to get a lot of data on there, because when you're running tests at this scale and you're running 200,000 tests a day, just that 200,000 tests a day is not going to matter because your database is isolated to just that run. But that run could have, a lot of tests, and that database is going to grow as you run the tests. So you want to have it as small as possible. All right, we just kind of went over the create new setup data for each test through an API. We'll skip down to here. So as I was saying, the database will grow, as the test run goes. What you want to do to prevent that is delete the setup data after each passing test. So as your tests are running, you're running 50 tests at a time on this branch that's been submitted. If that test passes, in the afterhook of WebDriver IO or Playwright, in that afterhook, delete all that data that was created for that specific test. So say you're creating a lot of data, you don't want to keep that data around because it could slow down the site 10 minutes down the line if there's a lot of suites and tests running for that specific run. You can delete all that data. And one way to do that is store what was created in the database, so you know what data to actually delete. So a lot about what I'm talking about is, you kind of need to be able to know development of the application. You need to be able to modify that. You need to be able to create the servers. You need to be able run the E2E stuff, E2E tests, and that framework. So you kind of need to have a grasp of a lot of these different concepts, or have people that you can get in touch with that can make those changes. Someone on the server team, maybe someone on the application team, and then someone maybe on the automation team, all get together and make all those changes to be able to get these things to run. If the branch passes all the tests, so the branch can, move to the next stage in the testing process and everything passed, what you want to do is you want to delete that site in the database. So there's no reason to really keep it around if everything passed, unless you want to, unless depends on your workflow at your company. If you want to have it so manual tester can use that, that's perfectly fine. Keep it around. But if they don't use that, just delete the site, because it's not needed anymore. And if the branch fails on some automated tests, you don't delete the site, but you leave a link to, in a comment on GitLab or GitHub or Jira or wherever. You leave a link to the test where it failed, so the developer can go in there and run the failed test and try to fix it and see what's going on. All right, we're almost done. So let's say, like, at a large scale, let's say you have, a bunch of developers and you have a few people on automation team. Well, it's more important that you get the branches out that the main developers are creating, so the clients can get those fixes or new features. You want to get those out fast. When a developer, maybe on an automation team, is creating the tests, you don't want those tests in the pipeline to slow down other branches getting out. So what you want to do is, for those that are actually the developers that are creating the actual tests, you want to put those in lower priority jobs, meaning have a separate job for that. Have those run, and if those take hours to get out, that's fine. We want the main developer branches that are going to affect the clients to get out quick, whereas the ones that are creating the tests, those don't need to be out quick. So something to keep in mind. All right, I think that is mainly what I wanted to go over. So yeah, if you have any questions on this, just let me know. I'm happy to answer any of these. I probably missed some things, but I was kind of rumbling along on some stuff that I've learned as I've gone. But if you like this video, make sure to like and subscribe, and I'll see you in the next video.